Okay, this is related to problem 248. What is the sum of all prime numbers p less than 60 such that there exists a right triangle whose side lengths are all integers and whose hypotenuse has length p? So this is essentially a Pythagorean theorem problem. What you need to consider is what's called Pythagorean triples, the numbers that can form the relationship such as a squared plus b squared equals c squared, a, b, c are integers. The question is, how do you get these numbers, a, b, and c? Okay, there have been some mathematical results in the past that can generate what's called Pythagorean triples. And for example, 3, 4, 5, 5, 12, 13, these kind of numbers. And there's a specific set of Pythagorean triples which are called primitive, which means they don't have a common factor beside 1 among all these three numbers. And the way to generate them is by using integers, for example, m and n, which are positive integers. One of them is even, and they are relatively prime, which means that the greatest common factor of m and n equals 1. So by using this condition, you can generate a set of primitive Pythagorean triplets, which means the ones that are relatively prime to each other by systematically run through the numbers of m and n. So m squared minus n squared and 2mn and m squared plus n squared will be the result Pythagorean triples, and they are primitive. For example, m1 and 1 gives 3, 4, 5, and 3 and 2 gives 5, 12, and 13. 3 and 1 cannot be used because one of them must be even. And for 4, you get 1, 4, 1. So this becomes 15, 8, and 17. So this is another set. And 4, 2 cannot be considered because they have to be relatively prime. So you can consider 4, 3 then. 4, 3, 16 take away 9, 7, right? And 2, 24. And this gives 25. 7, 24, 25. These gives a series of the primitive Pythagorean triplets. These guys, 4 and 2, for example, they give another set of Pythagorean triples, but they are non-primitive. And they can be constructed by another primitive Pythagorean triples. For example, for 4 and 2, 16 take away 4, 12, and then 16 and 20, right? So 12 squared equals 16 squared plus 20 squared. This is true, but they have a common factor of 4 in them. So this becomes 4, 3 squared equals 4 squared times 4 squared plus 4 squared times 5 squared. So cancel out 4 squared. You get 3, 4, 5. 3 squared, 4, 5, 4 squared plus 5 squared. This goes back to one of the original previous primitive Pythagorean triple. So we don't consider this kind of case here because they can be reproduced by another primitive Pythagorean triple. So by using this m and n continuously with these conditions, you can generate the least of primitive Pythagorean triples, which gives you just numbers that the triples that can be formed using Pythagorean relationship. And notice also the largest number here are all odd numbers. So all the even numbers are excluded because they are not prime. Okay. So if you want to get the prime numbers less than 60, for example, all you need to consider is the odd numbers. Actually, the odd result largest number. So that's what you need to generate. You just need to generate this long list and just continue until you reach 60. And that will give you a complete list of the prime numbers. And you can add them up to get the sum, to get the answer of 248.